Today we're going to talk about recursive equations for arithmetic sequences. So reminder, arithmetic means we have a common difference. And in this case, the common difference is going to be adding 4 each time. So the next term, you get the following term. All right, so let's say we only knew term 1 and the common difference of positive 4. How could we calculate term 2? What we would do is we would just do 5 plus 4. No tricks there. And we would get 9, which is true. Let's say we only knew the second term and we wanted to find out the third term. We would again do 9 plus 4, and we would get 13, and so on. Okay, so recursive statements have this phrasing, t of n plus 1. That means to find out the next term, you have to talk about the previous term. So let's label 9 as t of n plus 1, and 5 is going to just be t of n because it was the term after it. So that makes sense. This is the first term and this is the second term. You're taking the term number and you're just adding 1. So in order to find out what t of n plus 1 equals, which we know in this case is 9, you have to take the previous term, which we'll label as t of n, which is 5, and you would have to add 4 for it to be true. So the recursive equation for this sequence is t of n plus 1 equals t of n plus 4. Then we have to name one of the terms in the sequences so we know where it starts. So let's just start with t of 1, and t of 1 equals 5. All right, let's talk about this sequence. What is its common difference? And that would be minus 4. So if we wanted to figure out the term t of n plus 1, we would need to know the previous term t of n and then subtract 4. And we'd also need to know something about the sequence. We need to know a little schniblet of information. So let's talk about maybe t of 2. T of 2 equals 14. But let's say this was the only information they gave you. Oof, it's kind of a challenge. It looks like a lot of letters. I think you guys can do it, okay? So we know that the second term in the sequence is 14, and we know that we can find the next term by taking the known term and subtracting 4. So I'm just gonna kind of make some spaces. I want to know the first 4 terms in the sequence, and I'm going to fill in what I know. I know that the second term is equal to 14. Okay, but now I'm going to use this to find my other terms in the sequence. Okay, so if I know my second term, so I know n is equal to 2, and okay, so we're going to keep working down. 2 plus 1 is 3. So this will give us the third term. And we know what the second term is, where t of 2 is equal to 14. So if we continue our work down, t of 3, the third term, should equal 10. And let's check. I just wrote 3. I don't know why. Third term. That's why I wrote it. It would be 10. Okay, let's check back to our original sequence and see if that's true. Yes, it is true. And then from there, we can figure out the rest of the sequence. We know that the common difference is minusing by 4. So this one would be 6 because you subtracted 4. And to work backwards, this one would be 18. Sorry about that. All right, I would want you guys to try and write the recursive statement for this sequence. So pause this video, go rewatch the beginning if you need it. Okay. All right, if I wanted to write the recursive equation for this sequence, I always start with t of n plus 1 equals t of n, and then plus the common difference. And then you have to give me a little piece of information of the sequence. So maybe whatever the first term equals. So let's fill out what we know here. Okay, we know we leave t of n plus 1, and it's equal to t of n. And then the common difference in this is plus 3. And then you have to give me something about the sequence. I like to tell you what the first term is. So let's tell everyone what the first term is. T of 1 equals what? It equals -8. And this is a recursive equation. You tell me about the next term, let's say -5. You have to take the previous term, -8, and add 3. And that'll help you get to -5. So, perfect. Let's say you were only given this information. We know a little bit something about the sequence. We know that the 0th term is 3, and then that can help us go find the next term in the sequence. So I'm going to want to know 4 terms in the sequence. This is the first, and then dot, dot, dot. This is the second, this is the third, and this is the fourth. Okay. I don't include t of 0 in my sequence, but it is good to know that 0 is the first term. So maybe I'll make a table. Okay, 0 is 3. Now let's plug what we know into this equation. If we wanted to find t of 1, we would do t of 0 plus 1, because that'll end up being 1, equals, what is n in this case? It's 0. T of 0, and then I'm going to add 2. Okay, t of 0 plus 1 is just t of 1. T of 0 is equal to 3, just some substitution. So now I know t of 1 is equal to 5. And I can follow that pattern down. Okay, so let's fill that in. So the first term is 5. The second term would be 7. Third term would be 9, and the fourth term, if I can fit it, I don't think I'll see it on the screen, would be 11. And that's how you write a sequence given a recursive equation. I want you guys to try one on your own. Try this one. T of n plus 1 equals t of n minus 3. And we know that t of 0 is equal to 28. So I want to know the first 4 terms in the sequence. So pause this video and try on your own. Okay, I know that the 0th term is 28. If I wanted to find the first term, n has to equal 0, because 0 plus 1 is 1. So t of 0 plus 1 equals t of 0, because the n's have to match, minus 3. So we just consolidate. T of 0 plus 1 is 1, which equals t of 0 is 28. We know that, that was given. All right, so t of 1 equals 25. And then we know the common difference, so we can just follow that pattern. We're just going to subtract 3 each time. It's going to be 22, 19, 16, and so on.